Okay, people, tonight we are going to talk about reflections. So this is notes number 1-3-1. And keep in mind, we talk about reflections. We refer to those as flips. And we're going to be flipping a particular point or shape over a line of reflection. So these are the notes you should have. So let's take a look at the definition of reflection. So a reflection just means to flip a figure or a point across a line. And that line is called the line of reflection. And sometimes that line of reflection can be the x-axis, sometimes it can be the y-axis, and sometimes it just be a line like a y equals or an x equals. So if we take a look at this diagram right here, when we reflect a particular, in this case it's point B across a line, our reflected image, so our pre-image is B and our image is B prime. So when we reflect B over this line of reflection right here, we get B prime. And the distance from B to the line of reflection and from B prime to the line of reflection, those distances are equidistant. And the line of reflection is always perpendicular to the line that connects B and B prime. So we'll take a look at this because we'll be bringing in perpendicular slopes later on in this on these notes. So find the reflection of each point over the line y equals 0, which is the x-axis right here, and over the line x equals 0, which is the x-axis. So I'm going to go ahead and I'm going to plot the point -3, -1. So -3, -1 is right here. And we are going to reflect that over the x-axis. So when we do, I'm going to put an x there, reflect that over the x-axis. Keep in mind that the point from here to the line of reflection is the x-axis, has to be, the reflected point has to be the same distance. So we're one away here, so we need to be one away there. So our reflected point is going to be right there where x marks the spot. And our coordinates of the reflected point are -3, 1. So now we want to reflect that same point, which is right here, -3, -1, we want to reflect that over the y-axis. So again, this is our line of reflection. We are 1, 2, 3 points away from the line of reflection, so the reflected point has to be equidistant from the line of reflection, and so we'll make a star for that one. And we end up at, I know it's a little messy, sorry, we end up at 3, -1. So we're going to do the same thing for B and C. B, we're going to reflect over the x-axis and the y-axis, and the same thing with C. So B is the point 4, 0, which is right here. And if we reflect that over the x-axis, that's not going to change. So we're going to keep that as 4, 0. If we reflect it over the y-axis, and right here is the y-axis, that's our point of reflection, the original figure, the pre-image and the image have to be equidistant, so our reflected image will be right here at -4, 0, our reflected point. So last one, letter C, 0, 2, 0, -2, which is right here. We are going to reflect that over the x-axis, and when we do that, it gets flipped up here to the point 0, 2. then we're going to reflect that over the y-axis, and since it's sitting on the y-axis, those coordinates are not going to change. So they will remain 0, -2. So if you look at the coordinates when they're flipped over the x-axis, what happens to the y-coordinate? When it's flipped over the y-axis, what happens to the x-coordinate? So we're going to talk about making rules up for all of these transformations later on, but just pay attention to that. Okay, so for the next part, we want to take a look at some notation. So RM means the line of reflection. So this means the reflection line of M. So if this is R2, our line of reflection, if this is R over here, like x equals 4 is our line of reflection. X equals -1 is our line of reflection here. For C, it's y equals 4. For D, it's y equals -1. So we are going to plot the point 4, 1, and we're going to reflect that over the line x equals 4. So the point 4, 1 is right here. Our line of reflection is x equals 4, which is this line right here. And since we're reflecting it over the line that it's sitting on, this point, our image is not going to change. It's still going to be 4, 1. It doesn't change. So now we're going to try the point 5, 3, which is right here. The line of reflection is x equals -1, which is right here. And keep in mind, the image and the pre-image have to be equidistant from the line of reflection. So if we count over, it is 1, 2, 3, 4, 5, 6 points away from the 6 spaces away from the line of reflection. So we would do the same thing in the opposite direction, 1, 2, 3, 4, 5. And our reflected point will end up at -7, 3, which is right here. Okay, go ahead and try C and D, and then pause the video and then check back for your answers. We're going to reflect 8, 4 over the line y equals 4, and 4, 2 over the line y equals -1. Okay, so I'm going to plot the point 8, 4, which is right here. That is going to be reflected over the line y equals 4, which is a horizontal line that passes through y equals 4, and since the point is sitting on the line of reflection, the reflected point coordinates do not change. And then last but not least, 4, 2. Here's the point 4, 2. We're reflecting it over the line y equals -1, so our line is horizontal and it goes through -1. And again, keep in mind that the pre-image and the image are equidistant from the line of reflection, so it is 4, 1, 1, 2, 3 units away here, so it's 1, 2, 3 units away here, and we get the point 4, -4. Okay, we're going to use the properties of this line of reflection to answer the question on the bottom. Given the line of reflection is RK and A maps to A prime, we are going to find the slope-intercept form of line K. So if we go back to our diagram up here, the line of reflection is perpendicular to the line that connects the image and the pre-image. So think back to slope. If lines are perpendicular, their slopes are opposite reciprocals. So that's what we're going to do down here. So first, I'm just going to mention that here, the line of reflection is perpendicular to the line A, the line that connects A and A prime. So our line of reflection, which in this case is RK, it's perpendicular to the line that connects A and A prime. So if we find the slope of A and A prime, so if we find the slope of the line that connects these 2 points, and remember the slope is the change in y over the change in x, 6 minus 2 over 4 minus 0, we get 4 over 4, which is 1. So a perpendicular slope has to be -1. So if we have the slope of the perpendicular line is -1, now we need to figure out, okay, well, I need a point for it to pass through. And we know that the line of reflection is going to pass through the midpoint of A and A prime. So how do we find the midpoint? It's just the average of the x values and the average of the y values of A and A prime. So I want to find the midpoint of this because we know that they're equidistant. Equidistant means the midpoint. And so the midpoint would be 0 plus 4 divided by 2 over 6 plus 2 divided by 2. So our midpoint is the point 2, 4. So now we have a slope of -1 and the line passes through the point 2, 4. We have those two things. We can find the slope-intercept form of the line that has a slope of -1 and passes through point 2, 4. So we are going to use the formula for slope-intercept, which is y equals mx plus b. We know that y is 4. We know our slope is -1. Our x value is 2, so then we can figure out what b is. And we get 4 equals -2 plus b. So our y-intercept is 6. Our slope is -1. So the slope-intercept form of our line is -1x plus 6, or you could just write it as x plus 6. And we're going to practice with some more of these problems in class today. So to the video questions, the Google questions, multiple choice question number 1 and 2, be sure to enter these in the Google form. Point P has coordinates of 8, -2. What are the new coordinates after reflecting point P across the x-axis? Keep in mind what happens when we reflect a point across the x-axis. And write the equation of a line of reflection in slope-intercept form between the two given points. So refer back to that last question on the previous page. And again, if you have any questions, please ask them in the Google form.